Today we're looking at an impedance matching demo to show the rigor and capabilities we have at Mobile Microwave to design your broadband RF microwave network. In this example, I'm showing impedances gathered for a gallium nitride on silicon carbide RF power amplifier through the load pulling of the large signal model. As you may already know, we have access to over 100 large signal RF power amplifier models from which we can select and design and tune up for your particular application. So in this example, I'm just going to briefly show a few of the data points we look at while designing these matching networks prior to stabilization and some more complex activities that take place after this first pass design is provided for matching networks. So in this case, I have a 3 to 6 gigahertz example design, and I'm matching from a relatively low impedance to 50 ohms. The fundamental challenge with matching large signal devices such as RF power amplifiers is that the larger the die periphery size is, the lower the impedance is that you need to match to your system impedance, for example 50 ohms. And so there's a clear trade-off here for bandwidth and how much you can minimize the reflection from the load or source depending on what you're matching to. And so that's one of the fundamental trade-offs to know, and this is the kind of thing we handle daily at Mobile Microwave. So if you'd like to discuss with us any particular needs or consultation or design project, we can help you with that. So let's go ahead and look at what the matching process looks like as I tune various elements. Just to show you a demo of what it looks like as we're tuning these devices and modules. Of course, most of the work has already been done for this, and so I'm not doing it from scratch here. I'm just showing you the all of the knobs that we turn to be able to achieve the desired specifications. As you can see, the return loss is better than 10 dB across the band, and for most of the band it's actually exceeding 20 to 30 dB return loss. What that means is that the impedances that we're matching to 50 ohms here, most of them lie within the 1.1 to 1 Visor circle. In the green circle you can see, and at some frequencies, which is at the lower end of the band, to the 1.5 to 1 voltage standing wave ratio circle, and the red one is a 2 to 1 circle for reference. And so with that being said, for this simple example, I hope that you found this video useful. Stay tuned for more examples and methodologies that we use to be able to get the job done for your mission requirements.